Hi, this is Daniel from TrustGraph. Today we're trying something a little bit new, something a little bit along the lines of a whiteboard session without the whiteboard. It's going to be here. Watch this coming soon. And I thought a good topic to talk about, and this is going to be a multi-part series, is a lot of the thinking and philosophy behind why we've made the design decisions in TrustGraph. Because we often see a lot of comments on why do I need all these services? Why do I need all this infrastructure? I don't understand why I need all this. And I'm hoping that going through some of these concepts and design philosophy will help illuminate why you might need all of these features and why we think you might. And maybe you don't. And that's a lot of the thinking that we see right now in the AI space. We still see a lot of people are at that POC level. And when you're doing a POC, when you're doing a demo, it doesn't matter oftentimes. It's about, does it work? Can you show that it does what you want it to do? But then there's the how does this scale up? How can I make this reliable so that it's running 24/7 without somebody that has to manually intervene? And I thought it would be good to talk about kind of the basics of system architecture, which I don't see a lot of talk about anymore. I guess I learned all of this from my years in aerospace and seeing how very complex networks of very complex logic and processing were done for aircrafts. And it was always shocking to me that different aircraft manufacturers would take wildly different philosophies towards this. Without going into a lot of detail, uh, one particular manufacturer chose a almost totally monolithic design, while another had an extreme distributed design. And so I guess the good starting point is, what do I mean when I say monolithic? When I say monolithic, I mean that you had a central, in this case, what they called mission computer, a central service that everything connects to, that everything depends on, that must be reliable. Without that service, everything else fails. So, what do I mean by distributed? That's where you've decomposed the system components into lots of different modules where you have lots of options. So it's not a hard dependency. If one system in this very distributed model fails, the entire system doesn't fail. It can still operate to some degree and have some degree of resiliency. Now, if we think about it in a really simple way, we could say a monolithic architecture is just one service. So if we say it's a 95% reliable service, that's pretty easy to figure out how reliable your system is going to be for the most part. And 95% is pretty good. 1 out of 20 times, if you've been using, LLM APIs, your failure rate or just things happening, probably more than 1 out of 20 times. Sometimes way more than 1 out of 20 times. So then what happens if you have two of these services chained together? Well, if they're both 95%, what's the reliability of the system now if they're in series, if they're chained together, if the only path for data to flow goes through both? Well, that's an and situation. Both systems have to work, which means that's the product of both their reliability. So 0.95%. Actually, let's just do it as if it's three, just to make it simple, or just make it more interesting, actually. So three of these. So it's the product of all three. So 0.95 times 0.95, 0.95. And what do you get? 86%. So the 95% is now down to something that's not so great, 86%. Now, what if we take a parallel approach? So once we had one, we were at 95%. Once we had three, we were at 86%. So let's just say we take three components that are 86% reliable and we have them in a parallel configuration where if data can traverse any one of these, the system still can function. Now, I'm going to talk a minute about whether this is actual true redundancy, etc. So if they're 86% reliable, what do we think the reliability of is that system? So the math is a little bit different on that. We actually have to take the unreliability actually. So we're going to end up with 0.14 times 0.14 times 0.14, and then 1 minus that. And what do we end up with? A reliability of 99.7%, starting from just an 86% reliable component. Now, you're probably thinking like, whoa, 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 wait a minute. They're not all doing the same thing unless we're talking about true redundancy and you're having a triple redundant system. And you're right, that's true. But what I'm starting to get at is the idea of resilience and manual intervention. Because in your system where you have services chained together and there's a failure in that, it totally breaks the chain, which means you're likely going to need some sort of manual intervention or a service that's observing all of this to then go in and restart, and everything will have to go back to the beginning. Whereas in a parallel system, and you have the three components, and say one out of those three didn't produce the result that was expected, well, the system is still live, it's still up, and can just ask that service retry whatever it was trying to do. So you get a lot more resilience to failure, and you get system uptime, which again is really important for a deployed system that you're not going to be monitoring at all times. Again, for a demo or a POC where you're working with the client, you may be able to monitor it when it's being in use because you may know when the user is using it. But what happens when they say, okay, I want this to go live and it has to be able to run totally on its own without any intervention? All of a sudden, that becomes an issue. And when you think about what does wiring APIs look like? What does a state machine architecture look like? These are very linear flows, very series flows where one service depends on the next. And if any service in that chain breaks, you oftentimes have to go all the way back down to the beginning. And that's really how I want to start this conversation, is just thinking about what do these systems look like when you're wiring APIs together, you're using a state machine architecture, because those are easy to understand. I can easily draw a flow chart of those, a diagram. And it's a good starting point. And the systems I'm talking about, though, parallelism, as you can see, just calculating the reliability of it is all of a sudden much more difficult. The math starts getting much more difficult. Conceptually, it starts getting much more difficult. And that's, again, I think that's why you see a lot of the resistance to, do we really need all this stuff? I don't know if I want to, unless I really, really need it, I don't think I want to do it. And that's what we're going to do over the next couple of videos, is talk about, well, do you need it? And here's potentially why. And here's why we designed TrustGraph this way.